Hey guys, in this video I'm going to discuss ESTEST plugins. Specifically, I'm going to talk about what they are, what they're used for, how they're designed and implemented, how they interface with ESTEST core web components, and show you how to run a few of them and what they can be used for. So in any ESTEST server, you're going to see this link to plugins. If you click on it, it's going to go to a web page that's going to present a selection of all the plugins that are currently installed on this ESTEST server. The plugins themselves are scripts that are developed independently of ESTEST that are aware of our URXML data model and can access public data from the ExistDB XML database. These plugins are designed to implement specific data analysis that include post-processing and comparisons that operate on particular data sets with implicit knowledge about how the data is organized and what kind of information is represented. The plugins can implement, for example, visualizations of the atomic basis, or plots of the band structure, and even fittings of the equations of state, and calculate a bulk modulus. Again, these plugins don't operate on any old simulation data, but for appropriate data sets, these plugins offer a very efficient way to perform a certain analysis. Although in this tutorial we're going to run plugins directly off the server, most plugins can be downloaded and executed from the command line, often in different and more powerful ways. But on the server, the process of using a plugin begins with finding the URXML simulation documents that make up a data set. Suppose you've built up a collection of simulation results, such as the one I have shown here in my account manager. From here, you can store them directly to a cookie that tracks members of a data set by UUID. Say I want to compare the band structures of silicon that I've computed in these two simulations. First, I need to store them. If I go back to the plugin sandbox, I can refresh this page and verify that they are indeed in the current data set. If I choose the band structure plot plugin and click on the link to run it, this plugin will generate a very nice band structure plot from the k-point and eigenvalue information stored in the URXML documents. I must also provide implicit knowledge about the lattice that was used in the simulations. In this case, both are FCC lattice. And I must provide the symmetry k-point sampling path that was used in generating their eigenvalues. In this case, the path has been L, X, to W, to K, to gamma, to L, to U, W, to L, to K, and then a bar to signify a discontinuity between the paths, and then U to X. We can see that our dataset has been input by their UUIDs, and this is done automatically by the interface. If I go ahead and run this plugin transform, it's going to give me an HTML web page that contains a plot to visually compare the two band structures, I can see here, and also provide tables that I can select from the k-points themselves to numerically inspect and compare their eigenvalues. We can also use the search interface to locate and store simulation data. Suppose I have a set of variable cell simulations that are identified with this identifier string. If I go ahead and search for it, I'll see that these documents are corresponding to the ones I used in this variable cell simulation data set. If I go ahead and remove my old data set and then store the current data set, I can go back to the plugin sandbox and verify again that this data set has been stored to the cookie. Now, if I choose the volume versus fit plugin and run this plugin itself, I can specify that I only have one data set that is corresponding of these 11 individual simulations. If I run this transform, I can get a plot that produces the fit of the energy versus the volume, fitting to the Murnaghan equation of state, and I also have a table that provides me with the parameters of the fit, including the bulk modulus. I'm sure by now you understand how this process works. For some data sets, a bit of reordering of the data is in order before we can run the plugin. For example, if we have the S22 data set, and we want to visualize these using the Twisty Mall plugin, we must first order them in the way that we would like, and then store them to the cookie. So first we remove all the old data, and then in our ordering of the S22 data set, we have them ordered 1 to 22, and we can save this order, and then going back to our plugin sandbox, we can refresh this page and inspect that we have our 22 datasets in order. Now if I choose the Twisty Mall plugin and run this one, we can select how many of the visualization cells to display in a table per column. So say we wanted 4 per column, and run this transform. We can get a nice interactive JavaScript visualization of the atomic basis in the S22 data sets. We can also calculate the interaction energies if we have data about the monomers of the S22 data set. In this different reordering I have seen here, we can simply again go back and remove the old contents of the data set, store a new data set by saving this order, and then go back to our plugin sandbox, refresh to verify that our current data set is stored in the current records, and then select the interaction energy plugin and run this plugin. This plugin is going to have our now 66 data set points, that is 1 for the dimer and then 2 additional ones for the monomer, for 22 data sets. We can again choose to how many we display in the table per column, and then we can also change the scale and unit that we want to see in our interaction energy. Again, if I run this transform, it will produce some nice tables with the interaction energy between the 3 data points, the dimer and then the 2 monomers. We can go back to our plugin sandbox and verify that the calculation of the interaction energies are indeed correct using another plugin, that is energy components. So if I run this plugin, now with the same data, I can specify that I want to pick out the total energy component in the 66 data sets. Again, I can choose some parameters on how much to display per column of the table, and then scale the unit. And then run this transform. And then we have a nice table of the total energies mapped to the individual documents corresponding to the dimer and the monomer, such that we can subtract the 2 values of the monomer from the dimer and verify very easily the calculation of our interaction energies. So I hope to have given you a good idea of how to use these plugins and maybe inspire some of you to develop your own. Thank you very much.